After introducing the most essential memory-related terminology, it is time to dive even deeper, and our first memory-related topic would be storage. In this session, you will learn about the major differences between mechanical storage and flash memory, which is mostly implemented in solid-state drives, or SSDs. There are quite a few important differences between SSDs and HDDs. The first one is the access time, or the latency. This is the time required for the read and write head to locate a sector on the hard disk. It is also the time it takes for data transfer to begin once a command has been executed. For HDDs, we have a latency of 5.5 to 8 milliseconds, but on SSDs we have no mechanical parts such as a read and write head, so the latency is set by default to 0.1 millisecond. Performance-wise, this is a very critical difference. Next we have the IOPS, or input and output per second. This is the number of input and output operations per second. And again, performance-wise, this is a very important difference between SSDs and HDDs. We can see SSDs support 6000 IOPS and above, while HDDs support up to 400 IOPS only. Next, we have the reliability attribute. This is the average failure rate of a device. Reliability is very important in mission-critical systems where hard drives or SSDs are frequently being used and replaced. Due to the mechanical nature of HDDs, we can see their failure rate is 4 to 10 times higher than SSDs. SSDs have only 0.5% failure rate, while HDDs have 2 to 5% failure rate. We can also see that SSDs are proven to be more efficient in terms of energy savings, which is the amount of power required for a device to work. SSDs consume 2 to 5 watts, while HDDs consume 6 to 15 watts. SSDs in this case would be much more cost efficient in terms of power consumption. The next consideration is the CPU power. The CPU power is the additional power expenses dedicated for CPU usage only. Average input-output wait is the time spent by the CPU waiting for an I/O operation to complete, and SSDs are again much more cost-effective as they only require 1% of average I/O wait compared to 7% on HDDs. The next is of course the temperature. This attribute corresponds to the temperature generated by a device. If you care about your device's lifespan, temperature is also an important consideration. Temperature levels generated by devices can also impact their reliability and increase their failure rate. As you can see on the chart, SSDs produce less heat than HDDs, therefore they are less susceptible to over-temperature failures. Next is the need for defragmentation. Defragmentation is a process that reduces the degree of fragmentation on a storage device. This applies only to mechanical devices. So essentially, data is written on random blocks on the disk or the file system. And to improve the read performance, defragmentation rearranges the blocks and puts the ones that belong to the same file next to each other, so the input-output head will not have to move too much in order to read the data. Again saying, this applies only on mechanical hard drives like HDDs, but since SSDs do not use the same type of storage and read and write technologies, defragmentation is no longer required for them. Sustainability is the amount of vibration a device can withstand before failing. This parameter is more relevant for enterprise storage, where disks need to be removed and relocated more frequently. SSDs can sustain a shock of up to 2000 Hz. However, HDDs are way more susceptible due to their fragile internal parts and the way they are manufactured. And now we finally found the first advantage of buying an HDD, the cost. The cost is normally measured per gigabyte, and it is still cheaper to buy HDDs nowadays. However, SSD prices are quickly dropping, and they have already become the standard for most modern computers and laptops. Another very important consideration is the storage capacity, which is the amount of raw memory for storing data on a device. The storage capacity is of course affected by the cost per gigabyte, and for that reason SSDs are still sold with relatively lower storage capacities, as they are still considered a little less affordable than HDDs. But as I said earlier, SSDs are quickly becoming the new standard for any type of storage, and prices are dropping very fast. Next consideration is weight. Weight is not always a high priority consideration, but it is taken into account in some industrial and manufacturing cases. As you can see on the chart, SSDs are lighter than HDDs. Therefore, they are more likely to be used for mobile devices industries, smartphones, laptops, and IoT devices. The next consideration is the amount of noise generated per device, which is measured by decibels. SSDs are way more silent than HDDs as they do not need to spin in high speeds. And lastly, the booting time is significantly shorter on SSDs than on HDDs. The average boot time from an SSD is about 10 to 15 seconds, while an HDD takes about 40 seconds to boot the operating system. So now we understand the main differences between flash memory and mechanical drives, or between SSDs and HDDs. In the next video, I will dive deeply into storage fundamentals, and I'll be introducing both personal and enterprise storage technologies and protocols. So thank you again for watching, and I'll see you on the next video, Storage Fundamentals. Thank you.